and we will go piece by piece, and you will see this will be very informative. And if you have gone through this and you have idea, I'm telling you, in future, whatever you're going to do, you have better understanding what basically you are doing and what you have to do next. Okay. And all your future concepts depends on these basics. So this is basically the switching part. I added this because I was so curious, to touch the lab. So that's why I added this lab. And we have since gone through the VLAN, Sprung, and NAT, ISP connectivity. So I thought I should add this as just for a fun. Just a minute, let me start the packet tracer. And I think it is not visible. So I'm gonna, deploy this from scratch. So let's start from, okay. So we will start from this. How your LAN look like. Okay, then piece by piece we'll connect this one and we'll further move this one. And if you think that it is going too much, then we can really stop at that point for you to feel some, okay. First thing first, we need to add these two computers. So you can select from here these two pieces. And then we need to add two switches. And we know what switches does. It will just broadcast whatever the information it will receive. Then I want to just connect these two very quickly. So I will use auto because I don't want to go into detail. For the sake of clarification and topology, to keep it neat and clean, I will just give the IPs. Let's say we are giving this IP from 192.168.1.1 and this one 192.168.1.2. Okay, so I'm gonna assign the IPs very quickly. I will go into the desktop under IP configuration and IP 192.168.1.1, and automatically it got the subnet. Similarly, this one, desktop IP configuration 192.168.1.2, which is on the same subnet. So my first step is I want to ping these two devices. Krista, can you tell me that whether I will be able to ping this device from this or from any end?
You're gonna go to command prompt ping.
Yeah. First, I will check IP config. Okay. So because I want to know where I am. Okay. And now I want to ping 192.168.1.2. Will I be able to ping this device?
Yes.
Why?
Because it's green and
the
connection are up. So I think there's no connection.
No, it has nothing. No. I want to understand the logic basically. Why it will be able to connect this one or ping will be able. Yep.
Because it's the same network.
Exactly. This is what I want to know. This is from the same subnet. That is the reason it will be able to communicate. And we have no any aggregation or segregation point in between, like the router. Okay. If we connect router in between, no, then the logic will tear apart and they will not be able to communicate. Switches does the broadcast and they have nothing to do with these IP subnets. Okay, so that is the reason it will be able to ping. So as you can see, I can ping. Okay, regarding the CAM table, I told you, if you click on the switch, go into the CLI and this is user mode. Want to go into enable mode and type command show MAC address table. Now you will see it is learning about these computers, these devices. So, for just for the clarification, what I'm going to do, I'm going to add the ipconfig/all the MAC addresses as well. So this is how you have very better understanding what is going on in our network. So ipconfig/all, this is my physical address, and you have better idea from where you can get these physical addresses. So this is, I think, for this device. I'm not wrong. 1.2. Yep. So this is the physical address of this computer, this machine. And if I want to get the MAC address of this one, I can get from here. Copy and paste. I will show you why I am giving these MAC addresses here, because we need it to understand the deep packet, what is going on. So, in my last section, I haven't touched upon one thing, which is, it's awesome, which is this simulations. If you click on this simulation, you can see we have multiple filters, ARP, BGP, Bluetooth, IPsec, POP3. These are all protocols. We can filter out. We can check how, just like, the Wireshark, if you want to know how packet traverse from one location to another, when it comes to Cisco packet tracer, this is the best. This is awesome. And I'm going to show here. So what I'm looking for.
That's awesome.
Yeah, I'm looking for ICMP, because if I go edit filter, you can see this is all selected. So if you want to deselect this one, just click once on this one. So you can see the filter has been cleared now. Now click on the edit filters and select ICMP, because we are going through the ICMP section currently, because ICMP basically is nothing but the ping. Okay, so we selected this protocol, and you can see it is there. Okay, so we have filtered out the ICMP. Now select this packet, add simple PDU, and once click on this one, and then click on this one. So now my packet is ready. If you want to go a lot in detail what this packet is, just click on that. This is my OSI model, which is talking about all 7 layers: physical layer, layer 2, layer 3, and these are public. And if I can correlate MAC address, you can see the MAC address if it is giving here for no, because we are here 00C CFBF can. So this is the MAC address. It is gonna show here. So it is telling me I'm sitting on this computer, and this is my situation. So let's go ahead, and if you click this one, it is saying if last event captured the forward. So I want to move forward. Click. You can see the packet has reached to the switch, and you can see at device what is coming from where, what kind of packet is this one. This is ICMP packet. Now if you go click, see what is going on here. We know that just by looking at this packet, we know that this is in layer, we're basically coming in port, and it is leaving port, egress port, ingress port basically. So this is our layer 2 Ethernet. This is our physical layer 1. It is saying it is hitting my fast Ethernet 0/2. which is correlate with this one. My exit interface is this one. And you know, when these two computers want to communicate with each other, they will use what? Initially, they will use IP to communicate. But if they don't have this MAC address information, we said, or we discussed in our earlier videos that it's going to use the ARC and with the help of MAC address. They have nothing to do with the IPv4 at this stage for the communication sake. First, they have to go through these MAC learning. Okay, what MAC address this computer has, what MAC address of this computer has. And these are burn-in addresses, you know, when the companies, like, you know, the companies that manufacturing network interface cards, they assign one unique IDs, which is known as MAC. In all universe, you know, for every device, this MAC will be unique. They cannot be same. If this is same, it's a blunder and the communication will not happen. That is why this is, you know, very essential part of any device, the MAC address. With the help of MAC address, they are going to communicate initially. Afterward, then they have found each other's MAC address, then they going to communicate easily. Otherwise, they send flooding, you know, if you remember, we talked about the flooding. So this is just the flow. So at this stage, now you will see the packet here. When you will click, now it went there. Okay. When you will click further, now it has received. And if you want to go a lot in detail, you can see now it has to do with the IP. You can see when it was here and here, it was just talking about layer 2 and physical. But now since it hit layer 3, and we know at layer 3 we have routers, we have computers, because they use IPs. So that's why now you can see layer 3 IP header source IP 192.168.2, which was coming from here, heading to where? 192.168.1.1. It is using what? The ICMP message, because we are sending ping packets, which has type 8. This is the code of this to represent. So it has received this one. Now it is ready to reply back. And reply is also, as you now you can see, it will be a flip. Okay. Now source IP is 1.1.1 and destination is 1.2, because now it is preparing itself to send back. So what will happen? Now it will go again back, because we are sending ping, and we know clearly that ping has request and the reply. So this is the reply. And it hit the switch. Now you will see, we know that switches have nothing to do with the switch, this layer 3. It has only to do with layer 2 and physical interfaces. So we will continue, and finally it is reached, and now it will give me information. See, I'm successful. So I have one-to-one communication going on with each other. But now, if you want to remove these filters, you just need to click this arrow button and just delete everything, and it's gone. But now we are still hitting on a simulation tab. We need to go into the real time. So now we are back. So this was the first step. We know that we have the reachability. Okay. Now we want to configure, if I show you, show VLAN brief. This is the command to see the VLANs. And you remember from your test out labs and the switching module we talked about earlier, means initially every port belongs to VLAN 1. So whatever the communication is happening by default, it is using VLAN 1. Now, the next step is I'm going to change this one to VLAN, let's space 150, and this one also into VLAN 150. Now, let's see what happens now. And how you can change to VLAN 50. First, you will need to create the VLANs on the same switch, which I'm going to do. Configure terminal mode, you will go into configuration mode because this is the configuration you are going to perform. And do one VLAN 150, which is very simple. That's it. You created one separate broadcast, VLAN 50. But right now you haven't assigned any port to this VLAN 50. If I show you VLAN brief, as you can see, one VLAN 150 is created. Before this was not there. It is active, but still no member from these ports has been assigned to this VLAN 150. Now I'm going to assign. You need to go into configuration mode. You need to go into the particular interface that you want to assign to, which is fast Ethernet 0/2. So to reach to that interface, you need to type this command, interface fast Ethernet 0/2. And if you want to see how many interfaces you have in this switch, this is a command, show IP interface tree. So it is telling me I have all the way from 0/1 to 0/24. These are my fast Ethernet interfaces. And then I have 2 gigabit Ethernet ports as well. And these are all currently down, except from these one, fast Ethernet 0/1 or 2. As you can see, this is up and up. And the reason is because we are connected with that one. 0/1 is connected here and 0/2 is connected here. So that's the reason it's up. Now let's assign VLAN 50 to that port. I'll just drag and drop some here to get some space. Now I'm currently on this switch. Okay, I need to go into interface, which is fast Ethernet 0/2. And now I'm going to make this host a member of VLAN 50. So the command is switch port access. If you are unclear about this command, what you can do, you can type switch port and then hit question mark. Further, it will dig deep. What you can do access mode, negotiation, these things. But I'm concerned with this one. Switch port access. Now it is saying which VLAN you want to give to this interface. VLAN, and now it's 124094. So these are the total numbers of VLANs we can assign. But we know that we have already configured VLAN 150. So this is, we want to assign VLAN 150. And you will see, the link activity as well, as soon as I will hit the enter. Because now it again going to go through spanning tree process. And because we changed the VLAN 1 information to 150, so that is going through the process of listening, learning, forwarding again. So this is just initiating. To confirm, what port has been assigned, what VLAN has been assigned to this interface. You can check show interface, show VLAN brief. And now we can clearly see fast Ethernet 2 has been assigned to VLAN 150, and VLAN 2 is not any more member of VLAN 1. So now the situation is this has become the member of 150, and this one is still the default VLAN 1. So my question is, Crystal, what do you gonna say about pinging? Can I ping that device? If I go ping 192.168.1.1, will I be able to ping that device?
I don't think so.
What is the reason?
They are not in the same VLAN.
Exactly. Now, just consider it like I have changed the subnet.
Yeah.
Okay, if I click, now you will see the ping is dying. It will not reach. So let's do it with the packet tracer now. If you want to clear, show all, click on this one. Now it has been cleared. Go to the edit, go to the ICMP, and we'll see where ICMP will stop. Okay, that's it. And select this one packet, and now I want to ping ICMP. So let's go here. Next, it is not proceeding. What is the reason? I want to identify. If you just click on this packet, as you can see, it is not leaving out this interface. Why? Because we have changed the VLAN information, the tagging. If you want to dig deep further, just click on inbound PDU details. Sorry. This is IP packet. We are not concerned about this one because we have nothing to do with IP right now. We know if our layer 2 is down, layer 3, layer 4, layer 5, these are useless. So at layer 2, which is Ethernet, what is going on? As we can see, we have source MAC, we have destination MAC. These are information are good. Then what is the odd thing that is making us not to reach that the other end? That thing has to do with the tagging 802.1 Q tagging. And Krista, can you tell me what is this thing?
This is the trunking protocol.
Very good, very good. This is trunking protocol. This is a piece of the puzzle that we are missing in that. Now you can tell me what is the solution, Krista?
Yes, we have to assign the PC in a VLAN, in the same VLAN.
Okay, let's assign that one. I will follow you. First of all, clear these. We will go into that switch.
Yeah.
Enable mode, configure terminal, VLAN 150. Okay, this is the VLAN we are assigning. Now we need to go into fast Ethernet 0/1 because we know we have to make this member of VLAN 150. Switch port access VLAN 150. To verify that, show VLAN brief, and now we can see whether it has become the member of that one or not. And now we can see, yep. Okay.
Yes.
Okay, that's fine. Just save this configuration. Either you can do type WR or
Copy run start.
Copy running configuration, startup configuration. That's it. Make a good habit of saving the configuration before switching off the device. Otherwise, you will lose the configuration. And if you remember, we talked about the RAM. This all information, whatever you are doing configuration, it is stored on RAM unless until you will run WR command or copy run command to save it to NVRAM. Okay, so let's this activity link go into the spanning tree modes, and once it turns green, I will try to ping again. That is the reason it takes a lot of time, because it uses STP old protocol, which is IEEE. And we'll talk about RSTP in a CCNA. This thing will be processed very fast when we'll use RSTP.
So
It's
I have
kind
a
of stuck.
question.
Yep. Go ahead.
I know that if it was one switch, we have to assign the interfaces to the VLAN. But like it's two switches, don't we have to configure something on the uplink?
Good point. I was about to go there, but let's go through this step. Okay.
Okay.
Very good. So, Gretchen, you have very good understanding about what we are doing. So, I think there is a glitch. Okay. Let's ping this one. Can we ping? Now the situation is this one is a part of 150.
Yes.
VLAN 150, and this is also part of 150.
Mm-hmm.
Now they are both in the same domain.
Yeah.
Can we ping?
No.
Why? Okay, I think it's stuck. Why? Because I enabled this one. Just a minute. I need to go into real time. Sorry for that. Just a minute. So you need to click on real time, okay? Not simulation. Just click real time. So you have this. Still stuck there. Okay. Anyhow, let's go ping. Yep, it is not pinging. Why?
Because we didn't configure the trunk.
Okay, and why we need trunk?
For the tag VLAN on the frame to be able to go through the link to reach the other switch.
Okay, that's fine. You're pretty right. If I try to ping now, it has turned into green, and still you can see we do not have reachability. Now let's take the help of packet tracer. Sorry, not packet tracer, simulation. And clear these filters. Edit the filters. Click on the ICMP because we are interested in ICMP packets. Now let's see what happens where for this packet reach. And select this one. We are sourcing from here and going to this destination. Now click on this one. We have reached this router happily. Now click next one, and we are stuck. Now go into the packet again. And it is going to give me a nitty-gritty detail what happened here. Go into inbound. Still, we are stuck. Why? We cannot see any information regarding 802.1q, which is trunk. And we are, pretty much know that VLANs has to go across trunk links. This frame has no any information about this trunking protocol. It has source MAC, destination MAC. This is type, which is representing Ethernet. This is frame check sequence, if any issues with the frame, and this is the data. That's it. So that is the main issue, and this is the troubleshooting, area as well. That is why we use Wireshark to troubleshoot what is happening in the packet. So the remedy is, or the solution is, let's delete this one and remove this filter, and just I'll clear this one. So the solution is creating this as a trunk link. And how we gonna make trunks? Very simple. Just click on the switch. Go into the interface, this interface, and tell him that you are trunk. So go into global configuration, interface path, it has this as one, switch port. Now we don't need to go into access. Access is for only VLANs. We want to make it trunk. As you can see, set trunking mode. Switch port mode and trunk, and hit enter. Now you will see again, it will go through STP process. So since we are here, I'll just save the configuration. And this is enough from one side. If we make it trunk, this is enough to make the trunk with this one, because this is already participating and passionately looking for to become a trunk, because this is crossover cable. But it is a very good practice to hard code the trunk on both sides. So we'll go into that switch, fast Ethernet 0/2, and make it switch port mode trunk here as well, and save the configuration. For the verification purpose, the command is show interface trunk. Very simple. Now you will see it is saying my port fast Ethernet 0/1, which is this one, is the mode on. Means I hard code trunk there, that please become a trunk. The encapsulation that is using 802.1q. There was another flavor which is ISL owned by Cisco, but they are phasing it out because it is using kind of encapsulation and it doesn't understand the concept of native VLAN. Here is the concept of native VLAN, and the status is trunking. So currently the VLANs which can go across this link are 1 all the way to 1005 through this interface. But the allowed VLANs are, which are basically configured, which is one by default, another one VLAN 150, which I configured. Okay. So basically it is telling me that only these two are capable to go through this. Actually can go all these one, but since these are configured, so these are currently going through this trunk link. And it is very slow. Really, this Cisco, they need to work on that they need to process these fast, but still, they are taking a lot of time.
Mr. Cameron, you are still on simulation?
Sorry?
Are you still on the simulation tab?
Yeah, real time, exactly. A simulation tab, why if I click simulation tab, And if I come on to this device, you will see a beautiful thing here. If I ping 192.168.1.1, if the simulation is on, just a minute, because I disabled the filters. If I add filter, let's say ICMP, and I just didn't select this one from this one to this one. I just directly went into my PC, and if I type, for example, ping this one, now it's stuck here, unless until I will hit this one. Okay, so this is the use of this simulation as well. Either you can define source and destination, or just enable the simulation process and just ping to the destination. Now you are directing this packet where to go. So let's delete this one. I hope you get the idea, and clear these filters as well. So everything is running right now. So what is your sixth sense saying, Crystal, whether we will able to ping this one or no?
Yes, you will be able to ping.
Okay, that's fine. It's stuck, but it should ping, by the way, because we have created trunk links. We have enabled 150. So let's verify once again. Go to the switch, and let's see first. Show VLAN brief whether we have 150, and it is allocated to fast Ethernet 0/2. That's right. And show interface trunk whether we have truncated or no. Okay, 150 is allowed to go to this. Now let's add on to this switch for the verification purpose. Let's see whether we have configured the mirror thing there. So show VLAN brief first of all. As we can see, fast Ethernet 0/1 is assigned to VLAN 50, and show interface trunk. Fast Ethernet 02 is enabled and it is trunking. So for me, there is no any issues. And let's check the IP as well, whether we have 1.1 and 1.2. Okay, so let's use the packet trace, the simulations to demonstrate what is the issue we are facing if we have issues. So let's enable ICMP. The filter is enabled. Now we want to send packet. Now it reach here. As we can see, it is green. Now it is proceeding, and we have the reachability. Now it will come back, and if this is tick mark, it means it has successful. But one thing very nice here, I will show you again. Just remove this simulation from real time, and then again use the filter ICMP, and just source from here to here. Okay, and click here and click here. Now go into the detail of this one packet. So select the inbound video details to take a look. Now see the packet. Before it was Ethernet without 802.1q. Now we have the tunneling, or the trunking is going on. And if you remember in the last module, I talked about it will add few things. These are the things: TPID and TCI. This is basically the protocol ID representing 802.1q tunnel. I'm already not tunnel 802.1q trunking protocol, but you know, in your some professional they also called it tunneling protocol because it is creating kind of tunnel, you know. Then this one TCI is tag identifier. If somebody give you this packet and ask you, can you tell me the VLAN ID? What you can do, open the calculator, and I will share the calculator as well.
We were able to see it before you.
Ah, really? That's fine.
Yeah.
That's fine.
Yeah, we can see.
See, okay. You need to go into this programmer mode where you can see hexadecimal off. Okay. Then just copy this information. Copy this one, this TCI, paste it here. Oh, sorry. You need to select hex because this is hexa information and paste it here. And you can see what is it written decimal 150.
Yeah.
Why, Christian?
I was saying the VLAN ID.
Yes, you're right. This is the VLAN ID. It's correlating with this hexa information. So you see the power of packet tracer.
Yes. Yes, indeed.
Further, if you want to go in detail, you can see this is ICMP packet. This is what I am sending. It has type 08, and 08 is ICMP's identification, just like this one. This one. This is the identification of your 802.1q. And this is the identification of your Ethernet. I think this is enough. This one until here. Okay. So we have reached, we have the solution until here. Now we are going to connect the router as well. Select the router. I usually prefer 2811. And as per our topology, yep, I need to connect this router with this one. So select any cable and connect like this. And let's assign the IP to this one as well under the same subnet. Let's make it 192.168.1.100. So at the switch point of view, you have to do nothing, just switch, just up this port. How? Go into configure mode, interface fast Ethernet 0/3, because this is what is connected with the router, and say no shut. That's it. No shut means initially my this interface was shut. I want to make it alive with the help of no shut command. But still you can see it is red because other end is down. So just write this configuration, close this one, go into this one. Go into the CLI. As you remember, we talked about, because it didn't find the configuration, so that's why it went into this wizard dialog. Wizard. And wizard is nothing that they will walk you through some steps so you can, you know, provision your this router, but which we don't want because we know how to use console. So we will type no, hit enter, go into global configuration mode, interface fast Ethernet 0/0, and assign the IP. 192.168.1.100, 255.255.255.0, and do a no shut. Now you can see these links around. So here comes the question, Crystal. Now I want to ping from this device. We know that using trunk link, I can reach this thing. Okay. But now I want to ping my default gateway, this one, which is nothing, just remember it just like a host machine, which is having this IP, just like this one. And I want to ping this one. Will I be able to ping this one?
Yes, because it's the same. It's the same subnet.
Okay, let's see. Nope.
Okay.
It is dying. Any idea, reason?
I wanted to ask why you didn't assign an IP to the FA03.
I didn't assign any IP to this one.
Yes.
Because this is just normal switch port. It is just forwarding whatever the information is coming, it's just spitting it out. That's it.
Okay.
I don't need to put IP. Why do I need to IP? Because routers have to do with IP things, not switches.
Okay.
But this is very good question, by the way. Okay, any idea, or I will proceed with the.
Oh, yes, we are in a VLAN configuration.
Very well.
I was still thinking that it was a default VLAN.
Very well.
Yeah.
Very well. So you need to go into
the switch
03 switch port access VLAN what 50.
Yeah.
And do it no shut once again.
So
and now you will see. Now tell me, will it be able to ping?
Yes.
Okay. Let's try. It takes so long. Meanwhile, we are here. I just want to give you another information. If you go into physical, you can see this router has these two fast Ethernet modules. But what in case if you want like further 8 to 10 modules? So what you can do, you can go into these fast Ethernet modules and you just can drag and drop into this area to get more ports. Okay, but for that you need to switch it off.
Yeah.
Okay, let's go and try it. Yes.
Yes.
You were right. See how piece by piece we are going?
Yeah.
So we are able to connect our default gateway. That is the reason, because why I'm saying always default gateway. Now it has the connectivity with the ISP. So since we are here, it is good habit, go into IP configuration and assign IP 192.168.1.100, which is my default gateway, this one.
Yep.
Similarly, this one, 192.168.1.100. And we know why we need default gateway. When we have to connect to the ISP, okay, we need a default gateway, first of all. That will help us to resolve and to reach these public IPs.
Okay.
If you want to talk locally, these devices are intelligent enough that they have idea that these devices are locally connected. But if you ping like jobskillshare.org, which is residing on public IP, let's say 67.65 something, no longest match, by the way. Okay, you can take the same idea. No longest match. So where it is going to go to the default gateway, which is this one. So this one will resolve this one. Okay, so far so good.
So far, so good.
Yep. Okay, let's add the ISP router as well. Let's pick this one. This is our ISP router. And let's very quickly connect this with this one. Now you are going to get the idea of how ISP works. So just change the name of ISP. And I'm gonna use IP something like public, so you have better idea. Like use it like 160. No, let's make it 99.99.99.x. Something different for these, because they want to communicate with each other. So they must have one IP in between.
Mhm.
So let's very quickly go into this router. CLI, they know, enable configuration mode, interface, gig 0/0/0, and assign IP address 99.99.99.99 with, let's say, this mask. Okay, and do it no shut. So copy this one and I can paste it here, so I have better idea. These are my ISP. And if you have gone through DHCP, that is very good. If no, just ignore these things and what I'm gonna do. But if you want to move along, I will appreciate. Let's change the host name to ISP, so you will have better idea what router we are at. Now I am going to create the DHCP for this pool 99. How we gonna do IP DHCP pool? We are going to assign the pool like our host pool. You are going to give name, and then you will give the same network from this range. Okay, so 99.99.99.0 with that subnet mask 255.255.255.0. And since we are here, we have other options as well. Like we can give the DNS server information from here. DNS server, let's make it 4.2.2.2, and default router, which is nothing but the default gateway. Means when this host will get the IP address from this one dynamically, it will know where to go. So this default gateway is for this one, not for this router. Okay, just get the idea. If you don't get, no problem. This is just for my lab purpose. I'm going to give the default router to this my device, same device, 99.99.90. And that's it. If you want to verify show IP DHCP pool, I can see it is handing over these public IPs from these range. Now we need to, now you know, I told you public IP that router has assigned for you, you don't have to configure. So how you gonna get that? You're gonna get that dynamically. To get that dynamically on your router, what you can do, go into your this router and name it first of all customer edge underscore router. Oh, sorry, host name customer edge underscore router. So you have better idea that this is at your end. This is just like access point. So just for sake of clarity, I'm just giving it access point. On my fast Ethernet 0/1, I want to access this IP dynamically. Configure terminal, internet fast Ethernet 0/1. This time I'm going to provide IP address, but what? To DHCP. Okay.
Okay.
IP address DHCP and hit enter and say no check. That's it. As you can see, the IP address has been assigned. If you want to verify show IP interface read, you can see this is your heading to your public, your ISP, and the method is DHCP. It is up and up.
And if it was,
on other hand,
like, you know, not DHCP, like let's say we don't have multiple IP addresses, is it the best practice to put the static, right, on that interface, because you have that one IP address, you know that it's not going to change.
okay, yep, you can type, like, if you want don't want DHCP, just you can go same interface, IP address, and if they will basically they will give you this IP.
Yeah. And this is a good, coming back to that one point, remember we were talking about, Christelle, that how does it work from the ISP end, and this is actually what's happening right now. This is where things are getting configured. Oh, we got an IP address, we put it on that F0/1 now, and now we're going to move on to other settings inside our network. After this, we don't care about what ISP is doing because it's running. It has its own setup going on from their side. They may give you some kind of tools to check their connections, whatever it is, right? Here, now you're going back into your normal network and trying to get out of it. And that's what's happening right now.
Exactly. And you can see I have manually defined, but you know, we prefer dynamically, because when we do dynamically, it comes with some other things like default gateway. Automatically, it will assign my default gateway, which I mentioned in my DHCP in ISP. So I will show you how. If I do show IP route, which is showing me my routing tables, and as you can see, the gateway of last resort, which is nothing, but it is talking about this ISP, and it has no any information. But if I go the same interface, which is this one, which is heading toward the ISP, and if I say IP address DHCP, and just good habit is shut it down, no shut, so you can get the IP. Now you can see now it received 99.2 because I assigned statically.
And for new guys, if you're watching, I'm sure Kamran is typing very fast. So some people may, oh, it's too fast. So slow it down.
No, actually, this is not the part of, you know.
Yeah. And so that's why I want to tell people that because we're moving into certain explanations over here. So if you still are interested in just capturing these commands, pause this video, get back.
Exactly.
You can move on.
Actually, you know, this has become my habit to go very fast. So it is like autopilot right now. So if you think that you have some confusion, you can stop me. So now this, if I do show IP route, now you will see the gateway of last resort is automatically configured. And another thing, that static route is also there. This is the reason logic behind DHCP, why they are giving you using DHCP. And you know, if they are giving you a DHCP public IP addresses, and the whole idea behind that, another is, you know, this will not be same the next day when you will come, maybe. Not this one. This configured, which is 99.99.2 on this interface. Maybe after 1 week when you will come, it will be changed to something else like 66, 55, something like that. So that is a good practice to keep it on a DHCP unless until you have very good documentation, and you have given this you know, these all things from the ISP, and they have directed everything to you that you have to use this by this way. Okay, so at this point, I'm gonna save this configuration. If I try to ping, my ISP 99.99.99.99. As you can see, we have a success here. So it means I can reach because it is directly connected. So let's see the situation on these devices now. We know at this point, we know that it has a reachability all the way to this default gateway. And the default gateway knows how to reach this one. So what is your sixth sense says, will it be able to reach this ISP public IP? Any guesses?
We are in a VLAN configuration. I think no.
Okay. Crystal, forget about VLAN. VLAN only
Okay.
locally significant. VLAN story ends here.
Okay.
And we know that with the help of VLAN, we are able to reach. Now we have another story, which is the story of routing.
Yes.
And I told you that VLANs only works in a switching environment. It has nothing to do with routers. So, okay, no problem. And if you had this doubt, I just cleared it. Now I think you have better idea. So at this time, what you say that whether we will be able to reach or not?
From the definition of the router is able to communicate, I think it's gonna pass, the ping gonna pass.
That's great. Okay. Yes, you're right. So let's try first. First try my default gateway.
Yes.
So it means I have reachability all the way to my default gateway. And I also remember, if we are not wrong, under desktop, just a minute, I have assigned default gateway as well. Means if it is something else, you need to go into default gateway. Go command prompt, ping. First, I will try to ping this interface, which is what, 99.2. So let's see whether I will able to ping or not. Yep, we have reachability. Why? Because this is directly connected. Let's see. Let's move one step further and try this one.
No.
It is time.
That's where 90% of the people, when they do labs, this is where they are stuck. 90%.
Yeah.
I love these labs, to be honest. You're doing a great job, by the way. And you're kind of separating it out because this is where people are. And if you look at FA0/1, clearly it's still connected to that network. So it knows it can reach there. So you know now through the VLANs, that's just internal part, but VLAN to VLAN, you still needed to know what trunking. And then through that, you went through all the way to this router. And then because of that router has this interface connected, it was able to do that. But now for that interface to go out of our network to go somewhere external, right?
Yep.
It's becoming a problem right now. So this piece is what we are trying to learn right now. What is this? So let's just find out.
So, Krista, what you suggest? What is the problem?
I think we need to configure a route.
Route for what?
For go to the other router, to the ISP router.
Okay, I'm going to give you a hint.
Okay.
These are our local LAN IPs. They want to communicate with what service? This is our public IP.
Oh yeah, we need NAT. Sorry, I forgot
Exactly,
about
exactly.
that.
No problem, no
Good
problem.
job.
This is our segregation point. And this router has no idea when this looking for 99, 99, 99. When this router, basically what is happening? It has workaround, by the way, but I don't want to make you puzzle here. The problem is this router has no idea about what this thing is. This is LAN.
Mhm.
It cannot communicate with this public IP. These are RFC 1918, which are not routable, not routable. So that is the reason we provide solution as a NAT here. And we have discussed that NAT what will do, it will translate your this local IP into public IP somehow, excuse me, to communicate with the service provider. Okay, so let's quickly create that as well. This is the last piece of our puzzle. If NATing is, if you feel it is like difficult, just, now I think this is being recorded and you can just move along one by one. So first thing first, we need to define our router. This is my inside and this is my outside. Okay, because the router is not intelligent enough, you have to tell him that this is going to be your inside network, this one, fastest and user, and this is going to be your outside interface, IP NAT outside. This is the first thing we have to do. Now router is intelligent. It has information that this is my local and this is my public. Another step which you haven't done, this access list, we have to mention this our router that this traffic is coming from which IP, which subnet basically. So this is beyond your this session, but I'm just adding it for our reference purpose in the future when we'll talk about, you have idea. So we are going to create access list, which is saying what, let's pick one. This is just for identification. I want to permit this traffic, which should match what, this subnet 192.168.1.0. This whole subnet I want to match. I can be more specific, like 1.1. In kind of, if we are doing static mapping, we will do this one-to-one. And in static mapping, we have to go one by one. But I'm saying that you need to permit this whole IP subnet range.
Yeah, I like that you're mentioning that, because I feel like we should connect it with those slides, those three: static, dynamic, and PAT.
Yep, yeah,
It's
exactly.
good that you mentioned that.
And this wildcards, it's nothing, just like inverse mask we talked about, and Crystal answered it very correctly. So inverse will be the opposite of the mask. And that's it. This is just one command. Why we need? Because in a NAT, we need to provide this command just to let this router know this traffic is coming from which subnet. We could have, multiple subnets. Router is blind totally. Router has only idea about this is inside, this is outside. He has no idea what kind of traffic or packet is going to hit. So we just defining here in a single line. Now here is the command I'm going to do for NAT IP. And we need to find the NAT, and where we have NAT. I'm on a NAT from where to where? Of course, from inside to outside. So I'll select inside, because inside I have mentioned on this interface port, fast FSGSW. My source is what? Just I created the list. Remember access list, this one? This is my source. So the list is, and I have to assign the number which is assigned to ACR. Where it is hitting or where it is going fast Ethernet 0/1. So interface fast Ethernet 0/1 overload. You remember we talked about PAT, port address translation. This is another name of that, overload. This is the name of PAT, sorry. Port address translation. So whatever the traffic it is hitting here, it will assign different kind of port number to that, to identification purposes. Because the same computer can generate multiple sessions from the same source and going to the same destination. Let's say we have like a Google server. We know this host machine is going to the Google server from the same IP, public IP, but with different session. Maybe the Google has some different multiple session coming from the source to the same Google device. You remember in that NetStat how it identifies using the port numbers. So this is the same concept here. We are going to overload. So this is the basic command. IPNet inside, you want to inside from which source it is coming. The list I mentioned here, this access list, which is on top of that. And then which interface it will leave out, 0/1, but do it PAT and hit enter. That's it. Save it. For verification, do show IPNet translation. Currently, because I'm not doing anything, so that's it's empty. For now, this time try. Let's see, and I'm hopeful that it will work because there is no any kind of issues. And do ping 99. So it is pinging. And if you want to verify this one, before it was nothing, because the ping has ICMP 4 requests and 4 replies. So these are the 4 ICMP, as you can see the ICMP. So this is the, by the way, the command show IPNet translation. It is gonna show me in this router how this router is going to translate my this inside. And we know it is request is coming from 1.2 computer. But it is gonna translate with what? This outside local. And you can see it is assigning different ports to that.
So for my tip, I want to remember that, Christelle, if I forgot, let me know that to share the video with you guys, because this is, I have done this on a real network. So now when you see this, you can clearly understand what's going on. And then you see the real network example, because I haven't explained this stuff, then it will make a lot of sense with you. Once you watch this, once you watch my video, and you got a lot of explanations now, you saw a practical example of this, how it works from all the way from story A, local everything, trunking, and then story B from needing a NAT to go out. Everything will make sense then. But of course, you guys have to still do a little bit more research on understanding if you want to learn more in deep, but things will come in future too in CCNA as well, right?
Yeah, exactly.
For now, I think that's for good enough practical things you guys can do to really understand this flow. To be honest, this is actually a small, not even small, even a medium-sized network can use this type of, this is a whole solution right here, to be honest. Of course, it's a little more than that, but for a beginner, this is a pretty good way to understand the importance of router over here, because we're talking about routing over here. And you see how important it got because you couldn't get out of to the public then. And that's why you needed router then. And for that to happen, you need to tell your router what to do specifically, from which interface it has to be assigned, and then specifically have to tell it what to do to be able to get out from this local network.
Yep. So one thing I just want to mention, until here, we didn't do any kind of routing. There is no routing involved. But from here, even we didn't use any routing protocols. You didn't ask me these questions. We didn't use routing protocols, but we're still able to reach this server ISP. Any guess what is the reason? NAT is doing netting, but still how on earth this computer is gonna reach this one? Crystal, if you can answer.
Because it's one hub, it's directly connect one truss.
Okay, but I can configure some other routes and still it will be able to reach this one, which is even not on the same subnet, even which is not directly connected, which is connected somewhere else. Any guess?
No.
Because we are using routing kind of static. This is also a routing.
Oh. This is the default.
This is static route. Default static route. And if you remember, we discussed about the believability 0.
Yeah.
Because this is like directly connected. So it is always going to prefer this one. Okay, so your lab ends here, this one.